Welcome you all. We are in Detail Electronics QE 039/049. We are discussing about digital logic families. We will start this topic from today's lecture. Myself Dr. Kishanu Kundu, Assistant Professor, Department of Electronics and Communication Engineering, GL Bajaj Institute of Technology and Management. Okay. So, let us start. We will discuss about the various type of digital logic family. So, a logic family is a collection of different integrated circuit chips that have similar input, output and internal circuit characteristics, but they perform different logic gate functions such as AND, OR, NOT, etc. Okay. So, based on the components and devices that it internally used, digital logic families are named as RTL, TTL, DTL, ECL and CMOS. What are the full forms? RTL stands for resistor transistor logic, TTL stands for transistor transistor logic, DTL stands for diode transistor logic, ECL for emitter coupled logic and C for complementary MOS. Okay. So, for each logic family we will discuss in the upcoming video lectures. Now, in this lecture we will discuss the characteristics of digital logic family in detail. So, this is the classification chart for logic families. You can see the ICs can be either bipolar or unipolar. Then bipolar can be two types, saturated and unsaturated. Then saturated can be classified as RTL, DTL and DCTL. DCTL is nothing but direct coupled transistor logic, and this is also can be termed as I square L, it is integrated injection logic, HTL and TTL. Okay. For unsaturated there are Schottky's TTL and emitter coupled logic ECL, and unipolar that be PMOS, NMOS and CMOS. So, this is the classification chart of logic families. Now, the two basic techniques whatever we have seen in the chart we are now discussing here. Technique ICs are bipolar technology and metal oxide semiconductor MOS technology. What are the bipolar families? The bipolar families of logic circuit construct essentially from components fabricate bipolar transistor on the chip. Okay. In the bipolar category there are three basic families called DTL, TTL and ECL. These are basic three categories, DTL, TTL and ECL. Okay. DTL uses diodes and transistors, TTL uses transistors, also become the most popular family in small scale integrated integration and MSI medium scale integration chips, and ECL is the fastest logic family which is used for high speed application. So, ECL there is an advantage for ECL is it is used for high speed application, right. Next, MOS families. The MOS family fabricates MOS metal oxide field effect transistor. The MOS category there are three logic families, namely PMOS, P channel MOSFET, N channel MOSFET and CMOS complementary MOSFET. Okay. PMOS is the oldest and slowest type, NMOS used for large scale integration field of microprocessor and memories, CMOS which uses a push pull arrangement of the N channel and P channel MOSFET is extensively used where low power consumption is needed, such as in pocket calculators. This is very important where we need low power consumptions. For that type of application CMOS are very effective. Okay. Next, in the bipolar saturated logic families, the bipolar transistors are used as the main device. It is used as at the switch and operated in the saturation and cutoff regions. TTL an example of the saturated bipolar logic. This is very important point. In the unsaturated bipolar logic, the bipolar transistor is not driven into hard saturation. This increases the speed of operation. So, the unsaturated bipolar IC such as Schottky TTL and ECL is much faster and compared to TTL. Already we have discussed that TTL ECL is the used for high speed application, right. So, here this is the reason for high speed, because this is increase the speed of operation, this is not driven into the hard saturation, right. That is why they are having faster speed. All these ICs are fabricated on silicon chips using different fabrication technologies. Okay. Next, now we will start discussing about the characteristics or parameters of a logic families. So, first voltage parameters, first are the voltage parameters. Ideally, the input voltage level of 0 volt and plus 5 volt for TTL are called logic 0 and logic 1, means like that this is 0 and this is 1. So, this is 0 volt and this is 1 is equal to plus 5 volt, okay, right. However, practically we will not always obtain voltage level matching exactly to these values, therefore, necessary to define the worst case input voltages. So, this is the VIL max, first one is VIL max, this is worst case low level input voltage, this is VIH min, worst case high level input voltage. What are they? This is the maximum value of input voltage which will be considered as a logic 0 level. If the input voltage is higher than VIL max, then it will not be treated as low input level. Got it? Next, this is the minimum value of input voltage which will be considered as logic 1 level. If the input voltage is lower than VIH min, then it will be not treated as the high input level. Got it? So, these are two terms VIL max and VIH min. Next, this is the V0H min and VOL max. So, here from the diagram itself will be more clear. First of all, we will check the definitions. What is VOH min? Worst case high level output voltage. These are the for input, these two for input, okay. VIL, I for input, they are like this VIL, this is I for input, L for low, then VIH, I for input and H for high, like that, okay. So, this is VOH, O for output, H for high. So, worst case high level output voltage. So, it is definition is this is the minimum value of the output voltage which will be considered as a logic 1 level. If the output voltage is lower than VOH min, then it will be not treated as high 1 output level, right. Then is VOL max, means output low, worst case low level output voltage. This is the maximum level of output voltage which will be considered as logic 0 level. If the input voltage is higher than VOL max, then it will not be treated as low output level. So, from the diagram itself it is very clear, this is for input voltages, means these are VIL and VIH, right, and this is for output voltage VOH and VOL, right. You can see this is the value of VIH minimum, VIL maximum, this is VOH minimum and this is VOL maximum. This is the VCC power supply, right. This is logic 0 and logic 1. Got it? Okay. Next, the voltage parameter can be shown in the detailed circuit consisting of gates as shown in the below figure. This is the NAND gate and NOT gates are shown, can be used of TTL, EC and CMOS of any other type. Okay. So, this is the NAND gate, we are giving the two low, we know that when both are low in NAND gate the output will be high, and when both the inputs are high of a NAND gate we will be having low voltage. Okay. So, next parameter is fan in and fan out. So, fan in is defined as number of inputs a gate has. For example, a 2 input gate will be having a fan in as equal to 2, okay, number of inputs. Fan out is given the maximum number of inputs for the same IC family that a gate can drive without falling outside the specified output voltage limits. Higher fan out, higher the current supplying capacity of a gate. For example, a fan out of 5 indicates that the gate can drive at most 5 inputs of the same IC family. This is very important. If any device having fan out as 5, what it defines? It defines that the gate can drive at most 5 inputs of the same IC family. Okay. Next, noise margin or noise immunity. What is noise margin? We all know the noise is an unwanted electrical disturbances that may induce some voltage in the connecting wires used between two gates or from a gate output to the load. What is noise immunity? Noise immunity is defined as the ability of a logic circuit to tolerate the noise without causing any unwanted changes in the output. A quantitative measure of the noise limit is called the noise margin. These are very important from exam point of view, right. They can ask you the parameters of logic families, otherwise they can take it some values like fan in, fan out, noise margin, separately they can ask you as short questions. Okay. Now, this is the diagram for VIL and VIH mean. We will first discuss this one and then we will jump to the diagram. In order to avoid the effect of noise voltage, the void levels VOH mean and VIH mean are adjusted to different levels with some difference between them as shown in the above figure. This figure. So, first of all we will discuss this thing. The difference between VOH mean and VIH mean is known as high level noise margin, and the difference between VIL max and VOL max is called the low level noise margin. You can see from this diagram, you can see this diagram, okay. VNH and VNL, these two parameters you can discuss. So, what is VNH? VNH VOH mean minus VIH mean, and low level noise margin VNL is VIL max minus VOL max, right. Got it? When a high logic output is driving a logic circuit input, any negative noise spike greater than VNH can cause the voltages to drop into the invalid range. Okay. And similarly, when a low logic output is driving a logic circuit input, any positive spike is greater than VNL can cause the voltage to go to the invalid range. Okay. So, I think it is clear. Then propagation delay or speed of operation. The output of logic does not change state instantly in response to the change in the state of the input, right. There is a time delay between those two events, which is called the propagation delay. Thus, propagation delay is defined as a time delay between the instant of application of an input pulse and the instant of occurrence of the corresponding output pulse. You can check it from there. This is input, one inverter is used, we are having output. So, input low, output is high, then output high, input is low, because inverter if you give low input to the inverter, it gives high output, if you give high input to the inverter, it gives the low output. So, but it can constantly instantly it is not changing, some delay is there. So, this thing from low to high, from high to low, some propagation delays. So, this is called TPH, from this is from low to high, this is from high to low, right. Again this is from high to low and this is from low to high. So, this is called TPLH and this is called TPHL, right. This is for inverter, same like this is for AND gate. Okay. So, what is TPHL? Here you can see what is TP, this is TPHL, this one, what is this? The propagation delay measured when the output makes a transition from high 1 to low 0 state. You can see here high 1 to low 0 state, right. Then what is TPLH? The propagation delay measured when the output makes a transition from low 0 to high 1 state. So, these things I think it is clear now, these 2 points. Okay. The values of TPHL and TPLH are not always the same. If they are not equal, then one which is higher is considered the propagation delay time of the gate. Okay. The propagation delays are measured between the points of corresponding to 50% level as shown in figure. You can check it out. We have taken the 50% level and with respect to that we have designed that. Ideally the propagation delay should be 0 and practically it should be as short as possible. The values of propagation delays are used as a measure of the relative speed of the logic circuits. For example, a logic circuit with a propagation delay time of 5 nanosecond will be faster than the one with having the propagation delay of 10 nanosecond. So, propagation delay should be as low as possible. Ideally, there should be no propagation delay, but practically the propagation delay should be as low as possible. Then is power dissipation. As a result of applied voltage and currents flowing through the logic families, some power will be dissipated obviously, and it will be in the form of heat. The power dissipation will be in the form of heat. So, the power is in milliwatts. Care should be taken to reduce the power dissipation taking place in the logic ICs to protect the IC against damage, because if overheating is there then IC can be damaged, right. So, to remove that, to excessive heat, to reduce the loading or power supplies. Okay. Another importance of power dissipation is that the product of power dissipation and propagation time is always constant. Therefore, the reduced power dissipation may lead to an increase in propagation delay. These are two interrelated. If we reduce the power dissipation, it can increase the propagation delay. Okay. Usually there is only one power supply terminal, and for any ICs is rated by VCC for TTL ICs and VDD for CMOS ICs. The power drawn by an IC from a power supply is given by the formula VCC into ICC. Figure of merit. The figure of merit of a logical family is the product of power dissipation and propagation delay. Both the terms already we have discussed, power dissipation and propagation delay. So, the product of both these things is called figure of merit. It is called the speed power product. The speed is specified in the seconds and power is specified in watts. So, already you have taken the formula. Okay. Practically the value of figure of merit should be as low as possible. The figure of merit is always a compromise between speed and power dissipation. That means, if we try to reduce the propagation delay, the power dissipation will increase and vice versa. Okay. They are inversely proportional. The speed power product is used as a common means for measuring and comparing the overall performance of different ICs. Suppose an IC family has an average propagation delay of 20 nanosecond and average power dissipation of 5 milliwatt, then product of merit will be 20 nanosecond in 5 milliwatt. So, it will be as 100 picojoules. So, figure of merit will be 100 picojoules, right. So, let us start up the next parameter, that is current parameter. In current parameter we are having again 4 terms IIL, IIH, IOL and IOH. As voltage parameter already we have discussed in the previous slide. So, here we are having VIL, VIH and VOH and VOL. So, similarly, as far as voltage parameters we are having the current parameters as well. So, that we are going to discuss. In IIL, low level input current, it is the current that flows in the input when a low level input voltage is specified in the ranges applied. Next, IIH, it is the high level input current. It is the current that flows into the input when a high level input voltage in the specified range is applied. Next is IOL, that is low level output current. It is the current that flows from the output when the output voltage is in the specified low voltage range and specified load is applied. And IOH is high level output current. It is the current that flows from the output when the output voltage is in the specified high voltage range and specified load is applied. So, like voltage parameters, these are all 4 current parameters IIL, IIH, IOL and IOH. Next, if the output current flows into the output terminal, then it is called the sinking current. So, you can be asked that what is called sinking current? Sinking current is nothing but if the output current flows into the output terminal, then it is called the sinking current, and if the output current flows away from the output terminal, then it is called the sourcing current. So, there is the difference between sinking current and sourcing current. The current parameters are displayed on the logic circuit. We can check this diagram. This is the current parameters. Already I have told you this is IOH and IIH. This is for IOL and IIL. Okay. So, here one NOR gate is there. We know when both inputs of a NOR gate is low, then it gives high output, right. Again this high output is given as input to a inverter. So, it will giving as low output, right. Similarly, here when both are high, then of a NOR gate is input are high, we are giving the output as low, right, and this is again giving as a input to a inverter to give a high output. Okay. So, these are the diagrams of these 4 parameters already we have discussed here. IIL, that is low level input current, IIS, that is high level input current, IOL, that is low level output current, and IOS is the high level output current. Next, here one thing you have to notice here, what is the direction of flow, that arrow you have to check here, that the actual current direction can be opposite to those shown in the figure depending on the family. So, we are having different type of logic families like TTL, DTL, RTL, ECL, CMOS logic. For different logic, the direction of current will be different. So, with that it can be changed. Okay. Next is operating temperature. The temperature, acceptable temperature for consumer and industrial application is 0 degree to 70 degree centigrade, and for military application it is minus 55 degree to 125 degree centigrade. So, this is the operating temperature for logic family. The performance of gate will be in the specified limit over this temperature range. If the temperature goes beyond this limit, then overheating can be caused, and due to that the logic family, logic gates can be damaged. So, we always try to maintain this temperature band from 0 to 70 degree for industrial and consumer applications, and for metal application it is been between minus 55 degree to 125 degree centigrade. This next parameter is invalid voltage levels. The operation of a logic circuit will be proper if and only if its input voltage level are kept outside the invalid voltage range. This is very important point. That means, the input voltage should be either lower than VIL or higher than VIH. Already VIL and VIH we have discussed in the previous slides. This is, you can see, this is VIL max and this is VIH max. Okay. So, here we are discussing that thing, that the input voltage should be either lower than VIL max or higher than VIH min, right. The invalid input voltage will produce an unpredictable output response, therefore, it is should be avoided. So, this invalid voltage level, if we work in this range, then it will give inappropriate output response. So, we should avoid this. When the output is overloaded, there is possibility of output voltage going into an invalid range. So, when the output is overloaded, so there is chances, the possibilities are there that output voltage going to an invalid range. Okay. So, in this lecture video we have started with logic families. First of all, we have discussed different type of logic family examples like RTL, TTL, DTL, ECL and CMOS logic. Then we have seen the classification chart. There are main two types are bipolar and unipolar, and unsaid bipolar, saturated and unsaturated, and unipolar is basically the CMOS and PMOS logic. Okay. Then we have discussed about the different parameters. In that we have discussed about voltage parameters, then we have discussed fan in and fan out, we have discussed noise margin, noise immunity, then propagation delay. From after that we had got about power dissipation. There is figure of merit. Here it is very important, figure of merit is the product of propagation delay time and power dissipation. Next we have discussed about current parameters, and then the operating temperature, and lastly about the invalid voltage levels. So, these are the reference. Thank you.